Instant AP with VPN and DHCP. In this module, we'll look at the DHCP options. We'll explain DHCP local, DHCP centralized, either L2 or L3. We'll look at DHCP distributed, L2 or L3, and we'll do some troubleshooting. The DHCP service for the client can originate on the IPs or from the local server, or again can originate from the corporate network. The default gateway can be on the IPv4 or in the local network, or can reside in the corporate network. There are several options when configuring the IP clusters to determine the location of the DHCP server or where the default gateway will be. The following is a list of IP VPN forwarding modes. External DHCP server. The IP cluster is an independent cluster and gets its IP address from an external server. No VPN is used in this mode. Local. The VC is the DHCP server and the default gateway. In this mode, traffic from the cluster can reach the servers in the corporate network. However, traffic originating from the corporate network cannot reach the IP cluster as the subnet is unknown. Local L2 is a local subnet and the default gateway is in the local network. Local L3 has the default gateway on the IPv4, but the subnet is local. Distributed and centralized services are made to work with the corporate network. Distributing the DHCP server to the VC and the default gateway varies with L2 or L3. Centralized services mean the DHCP server is on the corporate network, and the DG varies with L2 or L3. Distributed L2. The VC is the DHCP server giving out the corporate IP address, and the default gateway is in the corporate network. Distributed L3. The VC is the DHCP server giving out corporate IP addresses, and the default gateway is also the virtual controller. Traffic is routed to the corporate network. Centralized L2 uses the corporate DHCP server, and the default gateway is in the corporate network. Centralized L3 uses the corporate DHCP server, and the default gateway is the VC. Traffic is routed to the corporate network. From the More selection, choose DHCP servers. Here are the three DHCP options: local mode, distributed DHCP, and centralized mode. You can create the scope you need. From the main GUI page, you can click on the SSID, then click on VLAN. You can now choose the VLAN assignment method, then you can choose Custom for the VLAN selection method. You can select from one of the pre-configured scopes, or click New to create a new scope. There is a limit of 6 configurable scopes. Local DHCP. Local mode. A client sends a DHCP request on the associated IP. The DHCP request is sent to the VC, and the VC replies with a local subnet, like a 192.168 subnet range, and the VC is the default gateway. This is not a corporate subnet. All internet traffic is source netted with the VC's local IP address and sent locally. Corporate traffic is source netted with the VPN's inner IP address. For the traffic to return, the VPN address must be in the corporate network routing tables. Connections can be initiated from the branch to the corporate destination. However, connections cannot be initiated from the corporate destination to the client in local mode. This is one reason why this mode is not typically used in employee networks, because devices are not reachable from your corporate network. It is mostly used in local deployments. Let's look at an example of local mode configuration. First, create a DHCP scope that will assign the IP address to the client. The default gateway will automatically become the subnet's .1 address. Once the scope has been created, then modify the SSID and in the VLAN section choose Virtual Controller Manage and Custom, then select the named DHCP scope for the VLAN you just created. Side note, if the SSID was already configured with VLAN 11, then it will automatically change the SSID VLAN setting for the Virtual Controller Manage and Custom Local VLAN 11 to match the DHCP scope that was created. So if the SSID is using VLAN 11 and the DHCP scope is for VLAN 11, the SSID configuration is automatically done. If VPN is used for local mode, we must make the VPN pool subnet a rooted VLAN, so it shows up in the routing table. The VPN pool alone would not be in the routing table unless it was set up as a VLAN in the controller. Since the client traffic is source NATed to the VC IEP inner VPN address, in this case 172.16.55.12, then any server trying to get back to the client needs to know how to get back to the 172.16.55 subnet. The VPN pool is in subnet 172.16.55. You must therefore create a VLAN and assign the VPN pool subnet to this VLAN. Use the show IP root command to see that the VPN pool subnet is in the rooted list. The Radius server must be configured with the IPVC's IP address. This allows the VC to send Radius requests to the Radius server. When using local mode, there are two methods for making sure the Radius will communicate with the VCs. Set up the VPN inner address as the client in the Radius. If you have several clusters, you would need to know the inner IP address and configure each one to be a Radius client. Or, on the controller, set up a VPN firewall role that will take all the Radius communications and source NAT to the controller's IP address. Therefore, the Radius only needs one address. Any new IP cluster will automatically work with this method. Centralized and distributed DHCP. The DHCP topic is worth reviewing. This is a pictorial slide on the DHCP modes. Local mode is similar to the local network at home wireless router. In local mode, the master IP of the cluster has a local subnet, for example, a 192.168 subnet, which is not an L2 or L3 extension of your corporate network. The master AP in the cluster is also the DHCP server and the gateway for the client. Local L2 and local L3 are local services, and the DHCP and DG are always local. Centralized and distributed mode are made to work with the corporate network. Centralized, the DHCP server is the corporate, and distributed, the DHCP server is on the IP giving out corporate addresses. Centralized L2 mode. Centralized L2 mode. The DHCP server is centralized and the branch is L2 extension. In this mode, the DHCP server and the gateway for the client reside in the data center, and the IEP cluster is essentially extending the corporate network to the branch office or your home office. Centralized L3 mode. As the name implies, the DHCP service in this mode is centralized in the data center of the corporate network, but the branch subnet is an L3 extension of the corporate address space. The default gateway is the IPVC with a corporate IP address. Distributed L2 mode. Distributed L2 means your DHCP server is the responsibility of the VC, giving out valid corporate addresses. The IP subnets are L2 extensions of your corporate network. In this mode, the IP acts as the DHCP server for a corporate subnet. The DG is in the corporate side, not in the virtual controller. Distributed L3 mode. The subnet is part of your overall corporate IP address space. The master IP in the branch acts as the default gateway and the DHCP. All traffic is routed to corporate, and corporate traffic is routed to the VC. Centralized L2 mode. A client issues a DHCP request that is forwarded to the corporate network. The client gets an IP address from the corporate server, and the default gateway is in the corporate network. All internet traffic is source NATed to the master's VC local IP address. Side note: if split tunnel is disabled, then all traffic is sent down the IPsec tunnel. Corporate traffic is not NATed and is simply sent down the IPsec tunnel to the controller. The IP address given to the client must be part of a VLAN that must exist on the controller. The corporate router or controller will be set up as the default gateway. The key thing to remember is that the branch network is a layer 2 extension of the corporate network. The DHCP server and the default gateway for the clients are in the data center or controller. Centralized L2 configuration. From the More drop-down, select DHCP. Specify the DHCP scope as Centralized L2. In this example, we are using VLAN 11. With split tunnel enabled, all internet traffic will remain local. Once you've created the scope, then modify the SSID. In the VLAN section, choose Virtual Controller Managed, and in the Custom section, select the named DHCP scope for the VLAN. If the SSID was already configured with VLAN 11, then this will be done automatically. At this point, the client will receive an IP address from the DHCP server at corporate. Keep in mind that VLAN 11 must exist on the controller. Centralized L3 mode. A client issues a DHCP request that is forwarded to the corporate network by the VC. The client gets an IP address from the corporate server, and the default gateway is the virtual controller. All internet traffic is source NATed to the master VC's local IP address. The IP cluster is an L3 extension of your corporate address space. The default gateway is on the IPVC with a corporate IP address. Corporate traffic is sent down the IPsec tunnel. This is a known network, therefore traffic can be routed to the IP cluster. Centralized L3 configuration. First, specify the DHCP scope type as Centralized L3. In this example, we are using VLAN 41. The scope 10.1.41 is defined, but this must exist in the corporate DHCP server. Once the scope has been created, then modify the SSID, and in the VLAN section, choose Virtual Controller Managed. In the Custom section, select the named DHCP scope or the VLAN. If the SSID is already configured with VLAN 41, then this is done automatically. At this point, the client will receive an IP address from the corporate DHCP server. The VC is the default gateway, and all traffic is routed back to corporate. This must be a known subnet at corporate. The bid process. In distributed mode, there is a bid branch ID process. This is a process where the DHCP scopes will automatically be assigned to the VC's DHCP server. In a distributed mode, the IP will be assigned a bid branch ID. Let's look at the bid process. In a new branch, the VC AP generates a branch key from its MAC. The branch key is generated by the VC is distributed to all IPs in the cluster. This is done in case the VC fails and another IP becomes the VC. It will have the same key. The VC forms an IPsec connection to the primary controller and obtains an inner IP for the IPsec. The VC starts the bid allocation with a registration message that informs the controller that it is a new branch. This transaction also contains the max bid, inner IP, MAC backup, and branch key. The controller ensures that the branch key does not already exist in the database. If it doesn't, then the controller will send a new bid. However, if the branch key and bid do exist, the controller will send the bid associated to the key. After the bid is allocated, the VC will calculate the L3 subnet for the branch and register it with the controller. Therefore, to ensure proper handling of IP and distributions of IP addresses, the controller and the IP go through a process called branch ID allocation. This process ensures that each branch in a distributed L2 or L3 mode is allocated a set of IPs that the master IP can then distribute to clients. Distributed L2 mode. Distributed L2 means your branch is the L2 extension of your corporate subnets and the default gateway is on the controller. The master IPv4 starts the bid process with the controller coordinating the subnets. A client issues a DHCP request that is forwarded to the VC. Client gets a corporate IP address from the VC. All internet traffic is source NAT to the master's VC local IP address. Corporate traffic is sent down the IPsec tunnel to the controller. The VLAN specified in the IP must exist on the controller and the controller will be set up as the default gateway. Distributed L2 configuration. When creating a new DHCP scope, select Distributed L2. The bid process will ensure that this subnet does not already exist. You must configure the VLAN, the default gateway on the controller, the DNS server. The IP range must be specified along with the number of clients per branch. This will tell the bid process what scopes will be needed to support this cluster's clients. Once the scope has been created, then modify the SSID and in the VLAN section choose Virtual Controller Manage. In the Custom section, select the named DHCP scope for the VLAN. Again, in this example, if VLAN 11 is already assigned to the SSID, then this step is automatic. If a DNS server is not configured, the client's DNS requests are resolved using the DNS server of the IP. If a corporate DNS server in the data center is defined and the enterprise domain is configured, then the IP determines whether the DNS traffic is forwarded to this DNS server or is source netted to the IP's DNS server. Distributed L3 mode. Distributed L3 means your branch is an L3 extension of your corporate subnets and the DG is on the virtual controller. The master IPv4 starts the bid process with the controller coordinating the subnets. A client issues a DHCP request that is forwarded to the VC. Client gets a corporate IP address from the VC. All internet traffic is source netted to the master's VC's local IP address. The corporate traffic is routed down the IPsec tunnel to the controller. Connections can be initiated either from the IP cluster to the data center or from the data center to the IP cluster. Distributed L3 configuration. When creating a new DHCP scope, select Distributed L3. The bid process will ensure that this subnet does not already exist. You must configure the VLANs, the DNS server, and the IP ranges to be specified along with the number of clients per branch. This will tell the bid process what scopes will be needed to support this cluster's clients. Once the scope has been created, then modify the SSID, and in the VLAN section, choose Virtual Controller Managed. In the Custom section, select the named DHCP scope for the VLAN. Again, if VLAN 41 is already assigned to the SSID, then this step is automatic. If a DNS server is not configured, the client DNS requests are resolved using the DNS server of the IP. In the IP, when specifying the range, be sure to use the network and broadcast addresses for the selected subnets. If you are planning to split the subnet with other clusters, then the range and client count must be the same. The controller will assign different bid numbers to distribute the subnet amongst the different clusters. Not having the same count will cause a problem of duplicate subnet, as both clusters will become bid 0 and start the IP address from the first network number. If the accumulated count exceeds the capacity of the subnet, then the last cluster would not be assigned a subnet. In the example given, both clusters are using the 10.1.40 subnet with a count of 100. Cluster 1 has been assigned bit 0, and the branch subnet is 10.1.40.0 with a 25-bit mask, having a possible 126 hosts. Client 2 has been given bit 1, and the branch subnet is 10.1.40.128 with a 25-bit mask, also giving it a possibility of 126 hosts. If cluster 1 had assigned a count of 200 clients, then cluster 2 would not be assigned an IP subnet. A group of IPs are all in VLAN 80. They form a cluster and elect an IP to be the virtual controller. A VPN is set up to a controller at corporate. We decide to put the users in VLAN 125 subnet 10.1.125. If setting up L3, then the default gateway will be in the virtual controller. And if setting up L2, then the default gateway and VLAN must exist on the controller. But all the users will be placed into VLAN 125 and subnet 10.1.125. Therefore, for this to work, all IPs in this cluster must also have access to VLAN 125. The switch ports, where the IPs are physically connected, must also be configured with VLAN 125. Regardless of whether you are setting up distributed or centralized L3, or even distributed or centralized L2, or not setting up VPN at all, this holds true. DHCP recommendations. Local. Recommended for guest networks with centralized captive portal servers. Centralized L2. Recommended only if multicast traffic to the branch is required. If not required, use L3 modes. Distributed L2. Recommended only if multicast traffic to the branch is required. Again, if not required, use the L3 mode. Distributed L3. Recommended for all deployments. Centralized L3. Recommended for deployments that require the use of a centralized DHCP server. IAP troubleshooting. Now let's look at the situation where the client is not able to receive an IP address using DHCP services in an instant VPN network. In an instant VPN network, the DHCP servers can either be centralized in the data center or on the IP. If you're using centralized modes such as centralized L2 or centralized L3, then the DHCP is centralized in the data center and the IP forwards the DHCP packets through the IPsec tunnel to the controller. If you're in distributed mode such as distributed L2 or distributed L3, then the IP acts as the DHCP server for the client. In distributed mode, the IP has to first successfully go through the bid process before it can become the DHCP server for the clients. The bid process between the controller and the IP decides the subnet or set of IPs that the IP can distribute or use to provide DHCP service for the clients. So if the bid process fails, then the clients connecting to the SSID won't be able to receive an IP address. Finally, in local mode, the IP acts as the DHCP server for clients and for local mode to provide DHCP services. The IP is not required to go through the bid process. For distributed mode, if the bid fails, then no IP address is given. Common client L2 issues are when the VLAN IDs are not mapped in the controller. This is the biggest issue in most deployments. Make sure the SSIDs are mapped to the correct VLANs. Also, in a multi-AP instant VPN deployment, the uplink switch connecting the IPs should support all of the user VLANs. Therefore, if you're using distributed L3 mode and if your VLAN is 80, then the uplink switch must support that VLAN 80. In this slide, we have listed some commands that you can run on the controller and on the IP to troubleshoot the issues we've discussed. The showlog wrapper command on the IP will actually show you the entire bid process if you are running into bid-related issues. You can look at these logs to make sure that the bid process was successful. The show IP detail table is a controller command. Here we can see two clusters of IPs. IP master is set up with a VPN tunnel and in L2 distributed mode with VLAN 11 at the branch. Master 2E, the other cluster, is set up with a VPN tunnel in L3 distributed mode. Based on the client count, this cluster has been given a smaller subnet of 10.1.41.32 with a /27 mask. The show IP table long is a controller command. Here we can see three clusters of IPs and the VPN inner IP address. IP master is set up with a VPN tunnel in an L2 distributed mode, using VLAN 11 at the branch. The key is used in the bid process and the subnet information at this cluster. VCLEO specifies a subnet of 10.1.40.0 with a client count of 100. This VC was given bid 0 and was therefore assigned the subnet 10.2.40.0 with a /25 mask. Master 2E is the other cluster, also set up with a VPN tunnel in L3 distributed mode, and also specified the same subnet 10.1.40.0 with a client count of 100. This VC was given bid 1 and was therefore assigned the subnet 10.2.40.128 with a /25 mask. In this module, we looked at the DHCP options. We looked at DHCP local. We looked at DHCP centralized L2, L3, where the DHCP server is found in the corporate network. We looked at DHCP distributed L2, L3, where the DHCP server is found on the IEP VC. And we did some IEP troubleshooting.